Today I'm about to give you guys emphatic proof that soil biology, as far as fertility in your garden, is the way to go. Now, I don't know if you guys remember or not, but there was a video I did a while back where it was like an experiment. It's where I inoculated the soil with compost extract, I inoculated the mulch with compost extract, as well as the cardboard. All three layers were inoculated with compost extract. And since then, I haven't added anything else in the form of fertility. The only thing else I've added is seeds and water. Before we get into that, remember next year, Sovereign Health Summit. It's linked down below. Barbara O'Neill's gonna be there. Dr. Ely's gonna be there. A bunch of awesome people are gonna be there. Tickets are linked down below. If you'd like a on-site consultation, if you'd like to achieve what I'm about to show you guys here today on your own property, or if you need help in general, just hit up the email down below. Hit me up for a permaculture consultation as well as a soil biology test. If you want to look at what the biology is like in your soil. Also, if you'd like to learn everything I know about permaculture, hit up the Patreon down below. You can get in for as little as $5 a month and learn everything I know about permaculture. Now let's look at the proof that soil biology works. All right, so we're going to look at this first bed right here. So remember, I inoculated this cardboard, the soil underneath the cardboard, and then I put down the inoculated cardboard, and then I put down the inoculated mulch, right? Now you can see this mulch is already breaking down. It's already turning color, breaking down. It's looking fantastic. Now, these right here are carrots, and as you can see, there are a ton of carrots, right? Now, I've never been successful with carrots for the most part. Like, I never get like, well, good germination rates like I have right here. I just don't have good luck with carrots. And look at this, almost 100% germination rates on the carrots. Now, it would be 100% if now I gotta say this quietly because the neighbors are outside, but their rabbit got in here and made a mess. And then I think one of my chickens got out from over there. They hopped the fence and then they went through scratching around here, and they scratched here, they scratched here, and then they scratched there at the end, and then right there in that patch right there. And those are the only places that I don't have good or awesome germination rates, right? So carrots, notoriously, I didn't even do the board method. I didn't do anything extra to increase germination rates on these guys other than just plant. Now we have a tomato that's trying to pop up just from, this is just a little volunteer tomato. And then also look at this, no weeds. I think here's one speck of grass. I didn't come out here and weed. Here's one speck of grass, and then here's another speck of grass, and that's it. And I didn't even get that one up out of the root, but that's it. That's it as far as weeds go. No weeds, no pressure. And then I have this pretty intense Bermuda grass over here, which is definitely going to try to make its way into the garden. If I'm not careful and if I'm not on top of it, it will take over the garden. It's just a battle. It's a battle of potential energies, but that's a different video. Awesome germination rates on the carrots. The only times I didn't have awesome germination rates is when a pest got in here. But on the topic of pests, you can see it's notoriously difficult to grow cabbage in East Texas because the pests come out. And we haven't had cold enough temperature just yet to fight off the pests, to make the pests go dormant. But you notice my cabbage, right? Pretty healthy cabbage, like I wouldn't say zero pest pressure, but very little pest pressure. Like, that's probably the worst of it right there. And it's also in a clump. So it's also in an area that's going to harbor more moisture and water. Like if we look at one of these cabbages that are out in the open, no pest damage at all, right? No pest damage at all. That's awesome. And then we have these clumps. The reason we have some thinner spots and then we have some clumps in other spots is because I have already gone through and then like thinned some out. Like this patch over here, I picked this one. This one's going to be my main guy right here. This one's probably going to be my main guy right here. And I'm just going through and thinning these, which is an awesome, like I put more seeds out here because I thought it wasn't going to do well. But carrots, awesome. Cabbage, awesome. Wonderful germination rates. Now the beets I have gone through and thinned just a little bit going through here, but again, awesome germination rates. No pest damage that I can see so far. I need to get out here and thin here pretty soon. Just like, look, y'all, I overplanted intentionally because I didn't think the germination rates are going to be that awesome. Also, the soil temperatures weren't even correct for these plants yet. It was still very hot for these plants, but these are all beets. And again, no weeds. You're not seeing any weeds here. So what's essentially happening in this garden? Why does compost work? Now, we've proved that it does work. fantastic germination rates with species that historically don't do well here at a time where we still have very, very heavy pest pressure, no pest pressure. So why is it working? Why is it increased germination rates? So the seed, whenever you inoculate everything around the seed and the water that's watering the seed and then the soil surrounding the seed, when you do that, you keep everything that the seed is going to need to germinate on hand. You keep all the biology right up against that seed, and then it germinates, and then it grows a root, and then that root, once it starts shooting down exudates into the soil, is going to be immediately met with whatever it needs immediately on demand. The soil biology, the soil food web is an on-demand system, right? So as the plant needs it, the biology is there to provide it in exchange for exudates, which is the sugar that it produces from the sun. The photosynthesis occurring converts that into sugar, and then it shoots that down into the soil with a grocery list, a list of things that the plant needs in exchange for this sugar. The microbe goes and gets it, and then it brings it back, and then it gets eaten by its predator, pooped out, and then the plant benefits. That's why it's important to have all the characters involved in the soil biology, not just a handful of them. Remember, there's like, what, 5,000 different fungi, taxonomied fungi. There's like 75,000 different taxonomied bacteria. There's a ton of characters, and those are just the ones that are taxonomy. Those are just the ones that are identified with a purpose. The rest of them, we're still trying to figure out. There's still a ton that have not been taxonomied or anything like that. And like, just to show that the diversity in soil biology is very, very important. Once you increase diversity, then these microbes start niching down and becoming like specialists in what they go and derive. In the beginning stages, they kind of play, you know, wherever they need to in order to fulfill the role. But that's why there's such high germination rates. Now, why is there very, very little pest pressure on these guys? So we've discussed, like as the seed germinates, it grows up, it's growing up in this what's called biocomplete soil, coined by Dr. Elaine Ingham. It's growing up in that, and as it grows and emerges from the soil, it's covered in that good microscopic biology. So if I were to look at one of these leaves under the microscope, which I might do in a future video, I'm about to head out of town, so bad timing right now, but in the future I might do that, actually do that experiment. I think that'll be a pretty cool one for those that are interested. But if I look at this leaf under the microscope, I'm gonna notice that most of the leaf I can't actually see. Most of the surface of the leaf I can't see. It's mostly covered in networks of bacteria and fungi, creating like a living armor over this plant. So whenever pests come in and then they don't actually create any damage on the plant, it's because they don't even have access to the plant. They can't even bite the plant because it's covered in this living armor. So that's why I have fantastic germination rates. That's why I have very, very little pest pressure, if at all, in this bed. And I think this is going to be a successful bed. And I think that method with the inoculating the soil, inoculating the cardboard, and inoculating the straw, I think it did pretty good. I still need to test the soil in here now that it's been a few weeks. I need to test the soil in here, see if it's fully inoculated or if I need to do more applications. If I need to do more applications, then the experiment didn't work as well as I was hoping it would. But if it did work and it's biocomplete, then we're good to go. And that's game changing, literally game changing. Now in this bed over here, I did plant some potatoes, and we don't have anything popping up yet, but also we had a vole pop in. So that might be the reason potatoes haven't popped up. I'll have to check that out. Not really the right season to plant tomatoes. And I still have time to plant something else sorry, not tomatoes, potatoes, if potatoes aren't working. Now in this bed here, I have moringa right here on the end. And then in between I have comfrey. I have another moringa right here. I don't know what happened to it. I think something ate it and then like chomped it down, and then it had to regrow, but it's very, very little. And when I planted it, it was not very, very little, but now it is. And then I got comfrey over here, comfrey there. Everywhere I planted the comfrey, it's doing fantastic. Some of it died back and then started coming back. That comfrey died back. I don't know why, but I have plenty of comfrey so I can replace it if need be. And then here we got another moringa here on the end. I'm gonna have to pull these out and transplant these soon because we're getting into colder temperatures. But so really the main production that's going on here is in that first bed there. This bed, when I get back from out of town, if this isn't pushing something out of the soil, then I'll plant something else. And then this bed right here, just producing comfrey, seeing if I can get any root cuttings before winter. And that's really it going on there. So for those of you that were wondering like, hey, why are we putting so much doggone effort into soil biology? Why are we putting so much effort into compost and everything? Now you know. look at the results of just good biology. That was one application in 3 different sections to create, I mean, 100% germination rates. What would you do for 100% germination rates? That's why I planted so many doggone seeds. You can then save seeds. I planted 3 times more than I needed because I didn't think the germination was going to be that good, especially with the carrots. I didn't even put up a board or anything. All I did was water it, and that was it. So, and then it does help to have like an automated watering system. I do have a video out on how to do that for the cheap. But yeah, thank you guys so much for watching, and until next time, we'll see you. See you guys at the Health Summit next year in October. Link down below, and if you need a consultation, hit up the email. Thank you guys so much. We'll see you next time.